All right, so I thought I'd do another one of these differential equations problems with you. This one comes from a different year, AP question, has a lot of the same characteristics you'll see as the one that we already did. So I don't have to stop and explain as much to you, but some of the techniques are different. This one is an applied problem. We're talking about at the beginning of 2010, a landfill contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at the landfill. Planners estimate that W will satisfy the differential equation dW dt equals 1 over 25, W minus 300 for the next 20 years. W is measured in tons, T is measured in years from the start of 2010. Use the line tangent to the graph of W at T equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010. They tell you that time is equal to T is equal to 1/4. Okay, so what we want to do, I guess one thing to notice about this is that it is an applied problem. It is dealing with tons of solid waste and time, where T is measured in time in years from the start of 2010. W is measured in tons. We can assume that both of these variables are going to be greater than 0. And actually, since it says it's an increasing function W, that also means that W is going to be greater than 1,400, I believe, greater than or equal to. So for part A, we want to find out what dW dt is at time 0. And what we're going to do for that is we're going to plug in what we know W is at time 0, which is 1,400. 1,400 minus 300, which is 1,100, 1/25 of 1,100, which is 44. And so then the problem says approximate the amount of solid waste that the landfill contains at the end of the first 3 months. So we're going to say W. Oh, sorry. It does say. Does it say use the tangent line? I guess I don't know if it asks you for the tangent line. We would want to do y minus y1 is equal to m times x minus x1 in here. So y minus 0 is equal to y minus 1,400 is equal to 44x or 44t. Or y is equal to 44t plus 1,400, and then W of 1/4 is going to equal 11 plus 1,400, which is 1,411. Okay, so for part B, it says find the second derivative in terms of W. Use that to determine whether part A is an underestimate or an overestimate of the amount of solid waste that the landfill contains at time T equals 1/4. Okay, so if I know that dW dt is equal to 1/25 times W minus 300, if I take the derivative of the whole thing, I'm going to do this implicitly, and I'm going to get d squared W over dt squared. Well, so the derivative of this, there's no t in it, but there is a w. So the derivative of this is just the coefficient. It's just 1/25. But then I have to multiply that by dw dt, okay, which is 1 over 25 times 1 over 25 times w minus 300, which is 1 over 625 times W minus 300. And then it also says use that to determine whether your answer in part A, 1,411, is an overestimate or an underestimate of the amount of solid in the waste. Well, what's happening here? Well, first of all, the first derivative is positive. It's greater than 0. And the second derivative, because W is greater than 1,400, the second derivative, d squared W over dt squared, is also greater than 0. So what's that going to look like? It's going to be concave up, some type of function where it's concave up. And if I use a tangent line to approximate something on a function that's concave up, I'm going to get an underestimate. And right, the actual amount that I want is going to be missing by whatever that part is there. So so it's going to be an underestimate. And then the part C asks you, which you usually will with a differential equation problem, is going to be to find the particular solution to that differential equation with an initial condition of W of 0 is equal to 1400. And so here's where I'm going to separate and integrate. I have dw dt is equal to 1 over 25 times W minus 300. I get W minus 300 dW is equal to 1 over 25 dt. Then I can take the integral of both sides. And now I'm going to get the natural log. Well, technically it's the natural log of the absolute value of W minus 300, but this is a convenient case where, because we know that W is always going to be bigger than 300, we can ignore those absolute value signs. And it just gets just a little bit easier. And I'm sorry, I'm missing an important part, which is plus C. And in the last video, I explained that you could put plus C on both sides, but they'd be different C's. But you could think of just putting plus C on the left and minusing it. And then you get one C on the right that captures both of the original C's. And this is how we're going to usually do it. Always do it. We're going to always do it. Just one plus C is on the right. And now we have the initial condition of 0, 1400. And so when I plug that in, I get natural log of 1400 minus 300 is equal to C, which is equal to the natural log of 1100. So we're getting closer to a particular solution. So now I can go back and I can say that the equation is the natural log of W minus 300 is equal to 1 over 25t plus the natural log of 1100. And we want to get this to where it's an explicitly defined function so that all we have is a W by itself. So what I'm going to do is I'm going to take both sides and I'm going to raise them to the power of E. And so on the left side, boom, that stuff is gone. I get W minus 300. And on the right side, this is a typical thing. Remember, when you're multiplying terms that have the same base, you add the exponents. So if you have a situation where you have the sum of two exponents, you can tease it out into being two separate terms that you're multiplying with a like base. So this is e to the natural log of 1100. And then I get W minus 300 is equal to, I'm going to move the coefficient to the e to the natural log of 1100 becomes 1100. I'm just going to move it to be the coefficient. This becomes e to the 1 over 25t. And finally, I'll get W is equal to 1100 e to the 1 over 25t plus 300. And what we'll find with a lot of these differential equation problems is that the constant, which originally is additive, becomes a coefficient when you do when you have to raise both sides to the power of e. What was added on becomes something that's multiplied at the beginning. So it's like going up an order of operations on your order of operations chart. But the final answer is W is equal to 1100 plus times e to the 1/25t plus 300.